Alright, so today we're going to need our workbooks and we're going to open them to page 67. Okay, on page 67 you should see this. Alright, so today we're talking about writing quadratic equations. Okay, and in order to write these quadratic equations, we're going to look at some different forms or different ways of defining a quadratic equation. Alright, so for your warm-up, I asked you guys to define focus and directrix. Okay, so who could tell me how they define focus?
The interior of the parabola lies on the axis of symmetry.
Okay, good. So you have two things that I wanted. Okay, so there's three things I want to make sure that you guys have when we define focus, and that is first a fixed point. Okay, fixed point, and second, inside parabola. Okay, fixed point inside parabola. And then the third thing I want to make sure you guys have is that it's on the axis of symmetry. Okay, so the axis of symmetry. So it's a fixed point inside the parabola. Why did I make that a D? Okay, that was supposed to be an A. I don't know why I did that. So this is parabola right here. So the three things I'll make sure you have is that it's a fixed point inside the parabola on the axis of symmetry. Okay, how did you guys define the directrix? Okay, so you have one of the pieces. Okay, so it's three things I want you to have here is that it's a fixed line, the second part is outside the parabola. Okay, and that it's perpendicular to the axis of symmetry. Okay, I just abbreviated axis of symmetry here. So it's a fixed line outside the parabola perpendicular to the axis of symmetry. Did I say parabola weird? Parabola. Okay, so the parabola. Okay, parabola. Oh my gosh, I cannot speak today. Sorry. Okay, and the last thing I want you to put a little star here. Okay, a little star for these two terms, and write both are equidistant. Both are equidistant from the parabola. Okay, so both are equidistant from the parabola. Alright, so make sure you have all of this down. Okay, so today, understanding those terms, we are going to define a quadratic. Okay, and the way we're going to define it is that our parabola or our quadratic is going to be defined as the points, all the points x and y that are equal distance from our focus and our directrix. Okay, our parabola is going to be equal distance from our focus and our directrix. Okay, right now that may not make sense, but as I work this example, we will see exactly what that means. Okay, so if we're given a focus, alright, if we're given a focus, and that point is 0, 2, okay, if we're given a focus, and that point is 0, 2, we will graph this. Okay, yeah, you'll need a sheet of paper for notes. Alright, and we're given a directrix. Yeah, and that will be y equals negative 2. Okay, so we have a focus and a directrix. How will we graph the line y equals negative 2? How do we graph that? What does it look like? What does it look like? Is it vertical or horizontal? Okay, it's a horizontal line where? No, that's positive 2. At negative 2, okay? So it's a horizontal line. It's not a trick question. We should know how to graph y equals. And you guys messed me up. See? It's your fault. Made me write it at 1. It's supposed to be at negative 2. So we draw our line. And y equals negative 2. Over there. In the third shelf. I mean the second shelf on the top. Okay? So this is what we should have so far. Alright? So, based off our definition, we know that the parabola is an equal distance between the focus, which is right here, and the directrix. Okay? And we know that the focus is on the axis of symmetry. Alright? When we graph parabolas, what other point is on the axis of symmetry? The vertex. Very good. Okay, so if we had an axis of symmetry and we had a parabola, we know the vertex is what lets us know where the axis of symmetry is. Okay, so we could find the vertex. We know that the parabola is in between or equal distance from the focus and the directrix. So if we counted 2 here, 2 down and 2 up, that's the same distance. Okay, so our vertex is at 0, 0. Okay, our vertex is at the origin. Okay, so now since our vertex is at the origin, we can look here, page 67. We're going to use this as notes today. Okay, we can look here and we will see that the standard equations of a parabola with a vertex at the origin. Okay, so we know the vertex at the origin, so we can look at these equations here. Alright, there's 2 sets. There's a set for when we have a vertical axis of symmetry, and there's a set for when we have a horizontal axis of symmetry. Okay, if we look at our graph, you'll see that we have what kind of do we have a vertical axis of symmetry or a horizontal axis of symmetry? What was that? Vertical. Okay, since our definitions say both of these points are on the axis of symmetry. We know it has to be vertical. A vertical line has to pass through both of these. So what we're going to do is we're going to look at this set of equations, okay? So just keep this to the side, and this is going to be what we reference. Alright? So the first equation that they give us is the standard equation. They tell us the standard equation when our vertex is at the origin is y equals 1/4 p times x squared. Okay? Y equals 1/4 p times x squared. What they also tell us is that our focus is, or the standard form of the focus is 0, p. Alright? The focus is 0, p. So with the information that's given, could you tell me what p is? What would p be for the focus and directrix that we were given? 2, okay? You see that? The p is the y coordinate. So here, our focus, the p value is 2. So what do you think we're going to do with this p value? What do you think we're going to do with this value of 2? Exactly, we're going to plug it in, okay? We're going to plug it in so that we can come up with our equation. Alright? So we have 1/4 times the p value. We said the p value was 2 times x squared. So what does this simplify to? What is 4 times 2? 8. So this simplifies to y equals 1/8 times x squared. So what we just found was the equation for our parabola. We don't know what the parabola looks like yet, but we know that this is our equation for the parabola. Okay, so given the focus, all we have to do is look at this value here, the p value, and then we can plug that value into our standard form to get our equation. Okay, so that's like problems number 1 and 2 on your homework. Okay, it says something about the distance formula. We're not going to worry about that. We're just going to use the focus and come up with the equation. Okay, so now what we have to do is we have to graph this function. Okay, so we already know the vertex is at 0, 0. Okay, we already know the vertex is at 0, 0. Now in order to graph a quadratic function, we have to plot at least 3 points. Okay, one point on one side of the vertex. We have to graph the vertex and a point on the other side of the vertex. Okay, so 3 points. The vertex and 2 points on the opposite sides. Okay, so in order to graph, we're going to use the general methods we've used before, and we're going to plug in values for x and find the y coordinate. Okay, so we're going to find our points. So we want to plug in values for x that are one that's less than 0 and one that's greater than 0. Okay, so if I were going to plug in a value, 4 seems like a good number to use. Okay, so if we plug in 4, alright, well, 4 squared is what? 16, okay? Well, 1/8 times 16 is what? 2, okay? 1/8 times 16 is 2, so this is 4 and 2, okay? Now we have to plug in one that's less than 0. Well, whenever we're working with parabolas, we want to choose a point that's equal distance from the one we just found. So 4 was 4 units away from 0. So yes, now we want to use -4. Okay? And when we plug in -4, you'll see that we'll get the same answer. Okay? -4 squared is 16. And 16 times 1/8 is still 2. Okay? So now we can plot these points. So we have -4, 2, and we have +4, 2. Okay? So we have 3 points. So we can now graph. Now, what were the 3 things that we said the focus? What are the 3 things we used to define the focus? What does the focus mean? It's a fixed point inside the parabola. Okay, so that second part, inside the parabola. If the focus is inside the parabola, which way is the parabola going to open? Focus here. Up. Okay, so since the focus is inside, it's going to open up. So knowing that, we can graph this parabola. Okay. We can graph this parabola. Now, if we think about the definition, okay, the definition said, or the definition for a parabola when we're speaking in terms of the focus and the directrix, is that the parabola is all points x and y that are equidistant from the focus and the directrix. Okay, so these 2 points that we found, well, this point here is 4 away. Okay, 1, 2, 3, 4 away from the focus. Okay, well, it's also 4 away from the directrix. So it's 1, 2, 3, 4, and 1, 2, 3, 4. Yep. Well, any point here along this is going to be the same distance. Okay. Any point is going to be the same distance. And that's what the definition means. That's how we define the parabola. Okay. So like problems number 3 and 4 in your homework, this is what we're doing. Okay. We're graphing the directrix, the focus, and the vertex. And once we do that, we will find 2 other points to graph the whole parabola. Okay. Another thing that you'll notice is that the standard form for the directrix is y equals -p. Okay. So our p we said was 2. Well, this line here we said was -2. Y equals -2. So based off what we said the standard form was, this is true. We have 2 and we have -2. Okay. So on page 67, that core concept, the notes that we were looking at the whole time, we apply this. 1, our vertex is at the origin. Okay. We can use these equations to graph, or to just write an equation when the vertex is at the origin. Alright. Now I'm going to show you guys what to do when the vertex is not at the origin. Okay. So if the vertex is not at the origin, we're going to turn to page 68, and we're going to use, I think my pen bleeded through. Okay. We're going to use these notes now. Okay. So when I'm speaking of the equations, I'm looking here on page 68. Okay, so make sure you have this out. And so now we have to be able to graph an equation whose vertex is not at the origin. So for instance, if we're given the equation Okay, the equation x equals 1 over 16 times y minus 4 squared minus 2. Okay, if we're given this equation, look at page 68. You'll see that there are two sets. There's one with the vertical axis of symmetry and one for a horizontal axis of symmetry. The way you know which one to use is to look at the y equals or x equals, whether it's y equals or x equals. Well, in this case, this is x equals. So we're going to use the second set on page 68. So we're going to use the horizontal axis of symmetry. Okay, so the x equals tells us that there's a horizontal axis of symmetry. So the standard equation for x equals is going to be x equals 1 over 4p times y minus k squared plus h. Okay. Are these two equations similar? Yes, they're similar. Are they the same? No, they're not written the same. Okay. This right here is standard form. We want to make sure whenever we're graphing, we want to get the equation into standard form. Okay. So we're going to manipulate this equation so it matches up with this one here. Okay. Well, the first part, the x equals, that's right. That matches. Okay. So the next, we're going to work left to right. The next piece is this 1 over 16. We know that the standard form is 1 over 4p. So it's 1 over 4 times p. What is p going to be? 4. Because 4 times 4 is 16. Okay. So here you always just want to rewrite it as 4 times p. Whatever p has to be to equal whatever is here. Okay. So the next step, we're going to have parentheses squared. We want y minus. Okay. We want y minus. Is this y minus? Yes, it's y minus. Okay. And then we have to find our k value. Well, what's our k value? 4. Okay. It's not negative 4, it's just 4. When it's in y minus, it will just be 4. Okay. And now the last part, we want plus h. How do we make this plus h? Okay. What's another way to subtract? We can add what? Yes, very good. We can add a negative. So we can say plus negative 2. Okay. So now we have our p, our k, and our h. Okay. So our p, you guys said was 4. Our h, our k, you guys said was 4. And our h, you guys said was negative 2. Okay, so knowing this here, we can begin to graph the parabola. And we can do so using the equations on page 68. So using the second set, since it's x equals, the standard form for the focus, okay, is going to be h plus p comma k. So what is our focus going to be, guys? What is h plus p? 2, right? 4 plus a negative 2 is 2. And what's our k? 4. So our focus is 2, 4. So we can go ahead and graph that. Okay. Alright, the next equation they give us is the Directrix. And that, the standard form for that is x equals h minus p. Okay? So what is h minus p? What is negative 2 minus 4? Negative 2 minus 4. Negative 6. Okay? So here we'll have x equals negative 6. So how do we graph this line? What is it going to look like? How did we graph the line y equals? How did we graph the line y equals 2? Or whatever it was. How did we graph the line y equals negative 2? What did that look like? How did the line y equals negative 2 look? On the previous example, it was a horizontal. Okay? So how will the line x equals negative 6 look like? Vertical. Okay? Vertical at negative 6. Very good. Hey guys, we got to remember this stuff. Okay? Got to remember that x equals a constant is vertical. Y equals a constant is horizontal. Okay? So that's what our line will look like. You graph that. Now, do you guys know the standard form for a vertex? I'll give you a hint. It involves HK. What do you guys think it is? I'll give you a hint. It involves HK. Yes. Okay, so the standard form for a vertex is HK. So we already know what our vertex is. Our H was negative 2. Our K was 4. So we can plot our vertex. Okay, so this is the vertex. This is the focus. This is our directrix. Okay. So now we have to find 2 more points. So we have the vertex. So now we have to find 2 more points. Okay, we said the vertex was negative 2 and 4. So using this equation here, we want to plug in y's now. Instead of plugging in x's, we want to plug in y's to find x. Okay, to find the other 2 points. So here, we want to find a y greater than 4 and less than 4. Okay. So a good y to pick 8. Okay, very good. Let's pick 8. Alright, so if we plug in 8, 8 minus 4 is 4. 4 squared is
16.
what's 16 times 1 over 16? 1. Because 16 over 16 is 1. And what's 1 minus 2? Negative 1. So x equals negative 1. Okay. So now 8 was 4 away from 4. 4 higher than 4. So what's 4 below 4? 0. Okay. So we want to plug in a number that's equal distance. Okay. So 0 minus 4. Negative 4. What's negative 4 squared? Negative 4 squared. 16. And we said 16 times 1 over 16 is 1. Then 1 minus 2 is negative 1. Okay. So now we plot these 2 points. We got negative 1, 0. Okay. Negative 1, 8. Now in the beginning of this problem, we said that we're using, this is a parabola with a horizontal axis of symmetry. So, very good. It's going to open to the right. How did you know it's going to open to the right? Very good. The focus has to be on the inside. Yep. Okay. So the focus has to be on the inside. And if we look at the distance based off our definition, we know that the distance from the focus to the parabola and the directrix to the parabola will be the same. Okay? These are equal to each other. It's a very good question. I believe it has to do with conic sections. Okay. Like calculus. It might be in geometry as well. Geography. I'm not sure. I'll check. Sure. Okay. So here, when we are given an equation, we want to make sure it's in standard form. Okay. Once we get in standard form, we have all the easy stuff. All we have to do is just find that your P, your K, and your H, and then you just plug those in to the formulas that are given. Okay. So page 68 and the previous page 67 are pages that you want to reference. Those are pages you want to know the equations for. Alright, so this is like a problem. This right here is like problem number 5. So problem number 5 on your homework, make sure it's in standard form and take this process here. Alright, now numbers 6 and 7, those you're given a graph and you're asked to write the equation. So those you're given a graph and you're asked to write the equation for that graph. Okay, so I'm not going to show you guys an example because I want you guys to look at number 5 when you complete it and be able to look here at number 5 and look at number 6, the parabola that they give you, and be able to come up with the equation. Okay, so I want you guys to think a little bit and work through it and try to write the equation for just a parabola that's given. Alright, so the first 2 sheets that we just covered, these 2 pages, that's homework. That's your homework, page 68, 1 through 8. You should be able to do all of those problems. Okay. Your next set of homework is page 73 in your workbook. Okay. So if you open to page 73, you have problems 1 through 8 here as well. Alright. So with these, okay, people today have liked this page a little bit more. Okay, with these, it's kind of the same idea. Once we're given a standard form, or once we're given certain information, we just need to apply the right equation. Okay, we just need to apply the right equation. So if we're given a vertex, alright, let's say 4, -1, and we're given a point that the parabola passes through. Okay, we're given these 2 things. Alright, a vertex and the point the parabola passes through. Alright, we want to be able to write the equation for this parabola. We have to use the correct standard form in order for us to get there. Okay? So when given a vertex, we want to use the vertex form. Alright? The vertex form of a parabola. Could you guys tell me what the vertex form of a parabola is? I'll give you a clue. Look around in front of you in your workbook. The vertex form of a parabola. Page 72. What is it? Very good. Okay. So if we do not know or do not remember, we can always look. Okay, we could always look in our notes. Alright, you're probably going to have to do these for this section. Alright, so this is the vertex form. This is the standard form. So to write equation, we got to plug in what we know into this equation. So we know the vertex, right? What was the standard form of a vertex in the last example? Very good. So it was h comma k. So this 4 is h, the negative 1 is k. So what can we do with that bit of information? What can we do with the h and k? Plug them in, okay? So if we plug this in, we'll get y equals a x minus 4 squared, and then the plus k, how can we write that? How can we write the plus k? If it's negative 1, can we just write minus 1? Okay, so what we just did is we plugged in the vertex, the hk, into our standard form equation. Okay, vertex form. So now, what can we do with this point that they give us? What coordinate does this 8 represent? X. What about the 3? Y. So we can plug this in as well. So 3 goes in for y, so we get 3 equals a times 8 minus 4 squared minus 1. Yeah, so now we want to, very good. So now we want to solve for a. This is the only thing that's left that we do not know, so you want to solve for a. Okay, so 8 minus 4 is 4, so we get 4 squared minus 1. So 3 equals 4 squared minus 1. And what's 4 squared? What's 4 squared? What's 4 squared? 16. Thank you. Alright. So what's the next step we do to solve for a? What's the next step that we do? What do we do next? You got to add 1 to both sides. Because normally we would write a16 as 16a. That's multiplication, okay? So we can't subtract 1 from 16. A16 is really 16a. So like you guys said, add 1 to both sides. So now we get 4 equals 16a. Then what do we do? Divide by 16. So what does a equal? What's 4 divided by 16? Simplify. 1/4. Okay. So a equals 1/4. So when we normally write an equation, we don't plug in numbers to the variables. We write it we write it with y and x, okay? We keep the variables when we write an equation. If we plug in for the variables, we get a point. We want the whole parabola. So all we're going to do is we're going to plug in the a that we just found and the h and the k that we plugged in earlier. So we'll have y equals 1/4 times x minus 4 squared minus 1. And that's our equation. Okay? That's our equation. So all we're doing is we're plugging in what we know. Okay? What they give us, we're plugging it into the correct form. Okay? The correct form. So if we're given a vertex and a point, we want to use the vertex form. Now if you look at your homework, they might give you, in this case, they give you x-intercepts and a point that the parabola passes through. So here, instead of the vertex form, we want to use the intercept form. Okay, the intercept form of parabola. So it's the same concept. We're going to take what they give us and we're going to plug it in, and then we're going to find the equation. Okay, we're going to find the equation given the information they give us. So it's the same process. Alright, if you look at your book, they indirectly give you the points here. We just look at the graph and we have a point and the vertex. So we'll use this vertex and this point to plug into the vertex form. Alright, for the other one, the intercept form, we'll plug in the intercepts and the vertex. Okay? Alright, well that's it for the day.